Assalamualaikum and hi. So, our group consists of 5 members, that is Nurul Alia binti Muhammad Nasir, Nurul Nasrin binti Abdul Razak, Nur Alifah Ilyana binti Muhammad Bakri, Muhammad Hidayat bin Saifullah, and Muhammad Aizal Izwan bin Abbas.
Question 1. For each of the following 4 networks, discuss the consequences if a connection fails. A. 5 devices arranged in a mesh topology. B. 5 devices arranged in a star topology, not counting the hub. C. 5 devices arranged in a bus topology. D. 5 devices arranged in a ring topology.
Assalamualaikum and good day. So today I would like to explain about the mesh topology. There are 5 devices that arrange in a mesh topology, which are device 1, device 2, device 3, device 4, and device 5. There are 10 links in the mesh topology that connect each of the device to another device, and each of the device has 4 links. If there is any links that fail to work, it will be easy to find out which link it is, but it does not affect any other links. There are difficulties within the mesh topology. When there is a bulk of wire, it can create a problem in reinstallation and reconfiguration. The primary disadvantage of the star topology is that the system works highly dependent on the function of the hub at the center. When there is any links that fail to operate, it will result in single node will be isolated. If there is a failure of the hub, the network cannot operate and isolate all the nodes. The bus topology, the transmission stops when there is a failure within the topology itself. When the drop line fails to operate, only the corresponding devices cannot operate. The ring topology provides only one pathway between 2 nodes. The ring network might be disrupted when there is a single link that fails to operate. A node failure or even a cable break might isolate every node that attached to the ring. The ring topology also a very orderly network as every device has the opportunity to transmit.
Question 2. Compare the telephone network and the internet. What are the similarities? What are the differences? Please discuss.
So, for similarity between telephone network and internet, firstly, telephone network and internet both switch network with circuit and packet switching. What is circuit switching and packet switching? Circuit switching is physical path between source and destination. All packets use the same path, reserve the entire bandwidth in advance, bandwidth wastage, and no store and forward transmission. But for packet switching is no physical path, packet travel independently, does not reserve, no bandwidth wastage, and support store and forward transmission. Second similarity between telephone network and internet are both are public network. The type of network where anyone can access and through it can connect other network or the internet. Next, the communication for both telephone network and internet can take place through cables such as LAN cable, fiber optic cable, or can be wirelessly such as Wi-Fi. Lastly, similarity between telephone network and the internet is telephone network and the internet both offer end-to-end data transmission. That means a network design method in which is application-specific features are kept communication to endpoint.
Telephone network is the first electronic network, whereas the internet is the leading network service provider at present. Both telephone networks and the internet are public networks, but there are a lot of differences. For telephone network, the terminal is telephone and modem, while internet is PC, mobile, and workstation. Telephone network just focus on voice, whereas the internet allows transmission of all kinds of data such as voice, file, image, video and so on. Bandwidth usage remains fixed or static in telephone network, but it be flexible or dynamic in an internet based on the application. For telephone, it use circuit multiplexing, while internet use packet multiplexing. Telephone network use analog as well as digital technique to conduct audio calls, whereas the internet is the network that only relies on digital techniques. Telephone network is a connection-oriented circuit switch network. That is, a connection must be established between the two endpoints, while the internet is a connectionless packet switch network. This means that packets can be sent without following an established connection. Network elements are used in telephone network is CPE, switch, mux, and cross content, while in internet is hub, switch, router, and bridge.
Question 3. An Internet Service Provider, ISP, is granted a block of addresses starting with 150.80.0.0/16. The ISP wants to distribute the block to 2,600 customers as follows. The first group 200 medium-sized businesses, each needs 128 addresses. The second group has 400 small businesses, each needs 16 addresses. The third group has 2,000 households. Each need 4 addresses. Design the sub-blocks and give the slash notation for each sub-block. Find out how many addresses are still available after these allocations.
An Internet Service Provider or ISP is granted a block of addresses starting with 150.80.0.0/16 and should be distributed to 2,600 customers by the group's method. To calculate the total addresses provided, we need to calculate the prefix length and suffix length. We know that to calculate prefix length is 32 minus with suffix length. The prefix length is 16 as the slash notation is 16. So we get the number of suffix length is also 16. Total addresses will be calculated by 2 power of prefix length, that is 16, and will be equal to 65,536 addresses in total to be distributed for 2,600 customers as the following. Okay, for group 1, the first group 200 medium-sized business each need 128 addresses. How we calculate? We will make 2 power of 8 and we will get 256. Why? This is because 256 is the next number in power of 2 after 200. Then we will find the total addresses by multiplying 256 with 128, and we will get 52,768 addresses. Then we have to find the suffix length by we make the log to 128. We will get 7. After we get it, we will find the prefix length. We will minus 32 with 7 and we will get 25. So for the addresses, for the first business, the addresses is 150.80.0.0/25 to 150.80.0.0.127/25. For the center business, the addresses is 150.80.0.128/25 to 150.80.0.255/225. and it will continue until the 200 business, which is 150.880.128/25 to 150.880.99.255/25. From the addresses, we can make a conclusion that the addresses from 150.80.100.0 to 150.80.127.255 will be unused addresses. So the next group of addresses will continue their number after these addresses. How to find the used addresses? Firstly, we will multiply 200 with 128 and we will get 25,600. This 25,600 is the addresses that have been used. After we found the used addresses, we have to find the balance addresses that can be used for 56 businesses of this group. We will minus the total addresses, which is 32,768, with the used addresses, which is 25,600, and we will get 7,168.
For the group 2, the second group has 400 small business, each needs 16 addresses. We use 2 power of 9 equal to 512. This is because 512 is the next number in power of 2 after 400. The total addresses 512 multiplied by 16 equal to 8,192. The suffix length 4 log 2 16 equal to 4. For the prefix length 32 minus by 4 equal to 28. For the addresses, first business we get 150.80.128.0/28 to 150.80.128.15/28. For the second business, 150.80.128.16/28 to 150.80.128.31/28. It will continuous until 400 business. For the 400 business, we get 150.80.152.240/28 to 150.80.152.255/28. 150.80.153.0/28 to 150.80.159.255/28 will be unused addresses. For the used addresses is 400 multiplied by 16 equal to 6,400. For the balance, 8,129 minus 6,400 equal to 1,792. It can be used for 112 businesses of this group. For the group 3, the third group has 2,000 households, each need 4 addresses. We use 2 power of 11 equal to 2,048. This is because 2,048 is the next number in power of 2 after 200. The total addresses 2,048 multiplied by 4 equal to 8,192. The suffix length 2 log 2 4 equal to 2, and the prefix length 32 minus by 2 equal to 30. The addresses for the first household, we get 150.80.160.0/30 to 150.80.160.3/30. For the second household, we get 150.80.160.4/30 to 150.80.160.7/30. It will continuous until 2000 household. For the 2000 household, we get 150.80.191.60/30 to 150.80.191.63/30. 150.80.191.64 to 150.80.191.255 will be unused addresses. For the used addresses, 2000 multiplied by 4 equal to 8000. For the balance, 8192 minus 8000 equal to 192. It can be used for 48 households of this group. For the total, group 1, the total addresses is 32,768. For the group 1 used addresses, 35,600. And the unused addresses, 7,168. For the group 2, the total addresses, 8,192. The used addresses, 6,400. And the unused addresses, 1,792. For the group 3, the total addresses, 8,192. The used addresses, 8,000. And the unused addresses, 192. The total unused 16,384 for the total address, and for the total unused address, 16,384 too. So the total 2 power of 16 equal to 65,536 for the total addresses. The used addresses, 4,000, 40,000, and the unused addresses, 25,536. The total addresses 2 power of 16 in class B equal to 65,536. So, to calculate out how many addresses are still available after this allocation, 65,536 minus 40,000 equal to 25,536, or 7,168 plus 1,792 plus 192 plus 16,384 equal to 25,536. Hence, there are 25,536 addresses available after this allocation.
So that's all from our group. Thank you for watching till the end and have a good day. Bye bye.